This is Mr. Parvez with Henrico High School. I'm going to make a quick video reviewing kinematics. Hopefully you'll find this useful. So the first thing is you need to understand a couple of the kinematics equations, and you have to understand some of the variables. So we're going to use D for displacement, and displacement, remember, means how far you are from where you have started off from, how far you've been displaced. It's different from distance, because keep in mind distance doesn't care about direction, displacement does care about direction. So for example, if you started off right here and you have gone 5 meters to the right, your displacement is going to be 5 meters because you're 5 meters away from where you started off, and your distance is also 5 meters. However, if you came back 5 meters to the left, and I'm writing a negative because I'm going to go with the standard protocol that to the right is positive, to the left is negative, just like up would be positive and down would be negative. In this particular case, your distance is 10 meters because you've gone 5 meters to the right and 5 meters to the left. Distance doesn't care about the direction. But your displacement, if you come back right here, you're back to where you started off, your displacement is exactly 0 meters because you have ended up exactly where you started off. So keep in mind, distance and displacement differ from each other because displacement takes into account how what your direction is. Distance does not care about that the direction. In your kinematics equations, one of the most important equations is average velocity. And average velocity is displacement over time, total displacement over time. Some people write it as a change in displacement over a change in time. And that's fine. You can write it that way, or you can write it as d over t. You can also write it as d final minus d initial over t final minus t initial. Keep in mind, most of the times your t initial is 0. So this drops out of the equation and you're simply left with a t. Your d initial sometimes is also 0, so this drops out of the equation, so you're simply left with a d. The 0 underneath the letter stands for naught. D naught stands for initial, so initial displacement and initial time. Some authors write it as an I for initial displacement and an I down here for initial time, and they write an F for final displacement and an F for final time, but we're not going to write anything for when we're talking about a final variable. We are going to write down a naught symbol for an initial variable. So your average velocity equation is displacement over time. That's something that you should save and keep in your memory banks. There's another way to calculate your average velocity also, and that can be simply calculated by saying average velocity is equals to your final velocity plus your initial velocity divided by 2. And that's very simple. Keep in mind it's a plus because you're adding two numbers and you're dividing it by 2. Keep in mind that all these kinematics equations apply only when the acceleration is constant. If the acceleration changes in a problem, you're going to have to break your problem up into separate parts. Talking about acceleration, the definition of acceleration is a change in velocity with respect to change in time. Now you can write it this way, or you can just simply go ahead and write it this way. Your final velocity minus your initial velocity over your final time minus your initial time. And remember, your initial time many times is 0, so this can drop out of the equation. So that's another important equation that you want to keep in your memory banks regarding your kinematics chapters. The other couple of equations that you want to keep away and a safe place is if you go ahead and take this equation, your acceleration equation, and you rearrange it for final velocity. By that I mean if you solve for v, this currently is solving for a, so if you solve for v, you would multiply both sides by t, so you'd multiply t on this side and you multiply t on this side, and t will move to the left side. And this is minus v naught, so you'd add v naught over here. And when you add v naught over here, it's going to go to the left side, and basically you're going to be left with a v over here, and you're going to be left with v naught plus at. You can write it that way, or you can just write it as v equals v naught plus at. This is simply, all I've done is I have multiplied, like I said, both sides by t, so the t disappeared, and the t showed up over here, and then I added v naught, and so I add a v naught right here, and so the v naughts disappear, and simply I've got v naught plus at, v naught plus at. So that's just algebra, moving the variables around. Remember, if you're dividing, if this variable is being divided, then to take it to the other side you have to multiply it, and if this variable is being subtracted, then to take it to the other side you have to add it. And simply that's another one of your kinematics equations that you should keep in your memory banks. The other two important kinematics equations that you want to keep away in a safe place are your final velocity equation, and that is final velocity squared is equals to initial velocity squared plus 2 acceleration times displacement. Now this is final displacement. So some teachers write it as final velocity squared is equals to initial velocity squared plus 2a final displacement minus initial displacement. This represents the displacement. Many times your initial displacement is 0, so this drops out, and your final displacement is your change in displacement. So you've got your kinematics equation right here, and then finally your last important kinematics equation is final displacement is equals to initial displacement plus initial velocity times time plus 1/2 at squared. All of these equations you should have in your memory banks when you're coming for any test in kinematics or any of your quarterly exams or your semester exams. So this is just a quick rundown of all your kinematics equations. The other thing you want to keep in mind is you want to know how to convert your units. So if you're ever given something like 100 kilometers per hour and somebody says please convert that to meters per second, you want to make sure that you know how to convert your units. So you've got kilometers over here and you want to change it to meters. So you know that 1 kilometer is 1,000 meters. So 1 kilometer is 1,000 meters. And the reason I put kilometers in the denominator because I want to cancel it out with kilometers. So kilometers cancels out with kilometers. Next, I want to change hours to seconds. So I know that 1 hour has 3,600 seconds. So 1 hour goes on the top and 3,600 seconds goes on the bottom. And you have gone ahead and canceled out your hours. So simply what you're going to do is when you calculate, you're going to do 100 times 1,000 and whatever you get, and then you're going to go ahead and divide that answer by 3,600, and that'll convert your answer to meters per second from kilometers per second. So that's going to happen quite a bit on many tests. They're going to give you the initial velocity in kilometers per hour, and then they're going to ask you for a final variable in meters per second. They're going to say, so you're going to have to remember everything has to be in the same units. So that just quickly reviews with you how you can convert from kilometers per hour to meters per second when you're talking about speeds and velocities. Finally, keep in mind, whenever you talk about acceleration, you must have the units should say meters per second squared. The reason for that is because acceleration is a change in velocity with respect to time. It's a change in velocity with respect to a change in time. And velocity, the units for velocity are meters per second. So you have meters per second in the numerator, and then you have a time in the denominator. You have seconds in the denominator. So you have seconds and seconds in the denominator. That's why you have seconds squared. So keep that in mind. Meters per second squared is for acceleration. Meters per second is for velocity or time. So hopefully this is a quick review on your kinematics equations and you find it useful.